Take me out to the ball game. Take me out to the crowd. Buy me some peanuts and Cracker Jack. Just so you all know, it's really important. When you sing that song, do not say Cracker Jacks. That's what everybody says. One, it's not plural. If you buy a box, it will say Cracker Jack. There's no S. The original song, if you look up the lyrics on the wonderful world of the internet, you're going to see that there's no S. So if you want to be a dork like me and sing it correctly and correct your friends and family whenever you hear that song, but you also like to be right, there's no S. Buy me some peanuts and Cracker Jack. Well, listen, it's almost baseball season, and I decided to put on my brand new Josh Wilson jersey. The A's last year, Sacramento A's, had the top 2 rookie of the years. They had Nick Kurtz, who was number 1. My son has his jersey. Really excited time for the A's this year. They're gonna put up some runs. I was a season ticket holder last year, but I didn't renew my tickets this year because I couldn't go to that many games. But I'm looking forward to going out to Sutter Health Park to check out our local baseball team. And if you're a Giants fan, good for you. All right, so today, oh, by the way, my name is Mr. Hendrickson, and this is Garage Math. There wasn't a fancy intro. My tech team isn't home from school yet, and they had me use a different app for my videos to put on my fun intro, and I'm not quite confident yet in how to do it by myself, so I went ahead and just posted this old school style. But if you do want to know or download that song, the last video I did, I put the link in the instructions. All right, let's talk math, shall we? A little rainy today. We've had some beautiful weather here in California, but it's still only February, so we have rain, which is cool. Here's what we're going to talk about today. We're going to talk about the difference between scale and scale factor. So ask your grandparents. There used to be these things called maps or an atlas. And what you would do is you would say, I'm going to go to Disneyland, and then your parents would buy this thing called a map. Ask your parents, grandparents. And they'd lay this map out, and there will be a scale on there. Even your old school maps in your classrooms, when you pull them down, it'll say this 1 inch is 50 miles. And then you're like, wow, how many miles is there from here to here? Well, it's 7 inches. That's not gonna take us very far to go 7 inches. Well, if 1 inch is 50 miles, then 7 inches is correct, 350 miles. So then you would have to do some computation, and that's what scale is, because you couldn't obviously fit the size of the United States in your classroom. Okay, so that's the general idea. If you're gonna build a skyscraper, and this is before computers and AI, then you would go ahead and build a model. Think of like Star Wars, the original movies where they used to have special effects departments. They would build a mini TIE fighter, and then maybe they would project it to be a bigger TIE fighter, although that's not true. I don't think they ever would build a bigger TIE fighter, although I think they might. Is the Millennium Falcon at Disneyland the actual size of the Millennium Falcon? Probably. So you use a model. Now you can scale up and you can scale down in case you want to build something super, super teeny that you can't see. You can build a bigger one and scale it down. And you use all sorts of math, but that's what we're not going to really talk about right now because that's common sense. So today's lesson is going to be fairly quick. We only had 2 problems. So you're going to go ahead and get out a piece of scratch paper, preferably a math notebook. I'm going to put my glove down, and we're going to go ahead and start knocking these out. All right, just a few little definitions, and then we'll get crack-a-lacking, okay? So a scale, let's read together. A proportional measurement, proportional measurements that compare a drawing or model to an actual measurement, okay? A proportional measurement that compares a drawing or model to an actual. So if you have a drawing or a model, it's the small model, and then you compare it to the actual. So this is what kind of we're going to use today. So you would have the fake thing, the model or the drawing. It could be 2-dimensional just on a piece of paper. It could be 3-dimensional, right? So a drawing would be 2-dimensional, actual model would be 3. And then you would compare it. Okay, so here's a big difference between these. These would be different measurements. So if you were going to build a big tower, you can have your model in inches or feet, and then your tower would be in yards, okay? So you could have inches over feet, and that would be your scale. You would have different units, okay? That's kind of the big difference here, because the scale factor is a scale without units, okay? It doesn't matter what the units are. It could be 1 to 12, which means 1 mile to 12 miles, 1 feet to 12 feet, 1 inch to 12 inches. It doesn't matter what the unit is, it's just no units, okay? So we're gonna actually go through these and you're gonna go, oh, I get what he's saying, okay? Because we're gonna have a little bit of fun today because we're gonna play with some toys. These toys actually have made an appearance in a previous video. All right, so you guys get this? Okay. All right, so we're just gonna get at it, but what we do have to remember is drawing model over the actual, okay? So I'm gonna make sure we have that on our thing here. I'm gonna check to see if we can see that. Oh yeah, okay. So this right here is Yoda. This is a model of Yoda. But what we're gonna do is compare the scale to the actual Yoda. Now, I did geek out and look up his height because evidently he has an actual height. I had to shave 2 inches off of Yoda. Sorry, you do get smaller when you get older. I used to be 6'3", now I'm 5'10 3/4. I used to actually be 5'11 1/2. But I made Yoda 2 feet because it just makes the numbers better. I didn't do it for the next example and it kind of makes it a little wonky. All right, so the actual Yoda is 2 feet. The model is 8 inches. So we're gonna figure out the scale of the model and we're gonna figure out the scale factor of the model, okay? So let's remember what we put right here. It's the model dimensions over the actual, okay? So the model is 8 inches, okay? Actual Yoda is 2 feet, okay? You notice these are different units. That's okay. For every 8 inches, there's 2 feet. And you can reduce these to make your life easier if it can, okay? So we'll divide both of these by 2, both of these by 2. You have 4 inches over 1 foot. That's it, okay? That is called the scale. For every 4 inches, it's a foot, okay? So if you wanted to build a 10-foot I'm not even gonna go with that example, okay? Okay, 4 inches over 1 foot, that's the scale, okay? Now we're gonna find the scale factor. Now remember what the scale factor, the difference is. It doesn't have units, okay? So the trick is you have to start it off with the same units because then you can just cancel them. So if we were gonna go ahead and put that, and you can put them both into feet and you can put them both into inches. It's easier for this problem to put them both into inches. Otherwise you'd have to make that a fraction or a decimal. We could do it, but we don't need to do it that way. Okay, so let's put this into the same units. So 1 foot is 12 inches. So 4 feet over 12 feet, okay? So the feets cancel. And you can reduce this. If you can reduce it, reduce it. It's easier if you can reduce it to one of them being 1. Sometimes you can't, which is the next problem we're gonna have. Now, 4 over 12 reduces to 1 over 3. Now, that is the scale factor. For every 1 of the model, you have 3 of the actual. And you'll notice there's no units because the units cancel, okay? So scale has the units, scale factor doesn't. Okay, let's try one more. Last problem, actually. I had lots and lots of choices. Lots and lots of choices. I picked one of my favorites. The 2000 American League MVP. This was back when regular baseball teams were allowed to have good players before the Dodgers and the Yankees and the Mets take them all. Ask your parents or grandparents. It was a wonderful time. And I used to go to the A's games all the time and get these amazing bobbleheads. Okay, so this is Jason Giambi. Well, speaking of Jason Giambi, when he became a free agent, where did he go? You guessed it, the Yankees. Sports used to be a little easier for most teams to compete, but it's fine. Now you just have to root for 1 or 2 teams if you want to win the championship. How about that Super Bowl? Here we go. Now, the model is 7 inches, okay? Jason Giambi is actually 6 feet 3 inches. Okay, so we're gonna find what the scale is using those numbers. So I'm gonna go ahead and set bobblehead down. Okay, now remember, it's a model, so our model over the actual. Okay, so the model over the actual. Let me get a green pen. Okay, model. Hey, why don't you hit pause really quick and see if you can solve these. This one you're not going to be able to get it to a 1 just because the numbers are kind of wonky. We can get it to a fraction and go further and further and further, but I just want you to go ahead and try these on your own and pause. Okay, let's see, the model is 7 inches. It's not green, that's blue. Is 7 inches, okay, so the model is 7 inches. And the actual is 6 feet 3 inches, okay? 6 feet 3 inches. I kind of wanted it all to be in feet to kind of make more sense. So what I did was I put 6.25 feet. So I want you to think about that, right? Because 3 inches is a quarter of a foot, 3, 6, 9, 12. I probably should have spent more time finding a different person to make these numbers not as stupid, but I already wrote the problem and I didn't want to redo it. So that right there is the scale, but we can reduce it, okay? You just divide this by 6.25, divide this by 6.25. You're going to end up with 1.12 inches over 1 foot, okay? So that means for every 1.12 inches is a foot, okay? So 2.24 inches is 2 feet. That's the scale, all right? The fact that it's a decimal to a 1 foot, but we have computers and brains, so we could probably work that out. Okay, that's the scale. Now, if you haven't done the scale factor, don't be lazy. Remember, it's without units. You have to turn them in to the same unit. So we can either turn both of these into inches, both of these into feet. I don't want to turn 7 inches into feet because we'd have all sorts of ickiness. So we're going to turn both of these into inches, okay? So 7 inches stays the same. 6 feet 3 inches is how many inches? 6 times 2, 12 is 72, plus 3 is 75. Now this is where I wish I could have got a prettier problem, but I didn't, so whatever. And then the inches go away. So 7 over 75 could be your scale. I divided it by 2 just to maybe get it a little smaller. It does, and I'm going to explain this in a second, it does introduce decimals. That's the scale. All I did was I divided that by 2, I divided that by 2, and you get rid of the inches because they cancel. I can't really go any further because you divide that by 3.5, you get a real icky forever decimal. So, but you can still have a scale with the decimal in it. It's fine. So, okay, that's the magical world of scale versus scale factor. I think you guys are going to understand that. And let's see, spring training has to be right around the corner. Kings keep on losing. The Warriors keep on getting hurt. The Sharks are doing pretty good. Football's over. And baseball's on its way. Okay, I hope people out there in the internet world are doing well. It's good to see all of you. I'll check back in with you guys soon. And peace. Take me out to the ball game. Take me out to the crowd. Buy me some peanuts and Cracker Jack.